Hey, it's Dr. England here, and this is for the EGN3214, Programming for Engineers, assignment 2, where you've actually got to do a fill in the blanks in an array, which is a very common thing to do. But I'm going to kind of give you the generic case here, where you're measuring something, and in this case, we're measuring a cumulative amount of something. Rainfall was the example that you have in your assignment, but you've got measurements that you've taken at various points in time, and you want to actually convert it to fixed points in time. So let's say this 0.5 value was taken at time 1.3, and you really just want it at 1, 2, 3, 4, 5, 6, 7. You want it at set intervals. So you have to do interpolation and actually get another set of values. I cover that in the parallel arrays video that you have. However, your assignment is not that hard. It's actually much simpler. In this case, and I'm going to solve this with Colab, I'm going to say, oh, okay, well, we just want to fill in the blanks that are missing in an array. So I'm just going to make up some values, 0.5, I'm going to make them cumulative, then 0, then 1.2, then 0, and then another 0, and then a 2.7, and then a 0, and a 3.5. I think that's enough. I think you can get the point from these. Okay, so now I've got this array with these values, and the zeros represent all the missing locations. That's missing data. Now, an array, so let's say A of 1. 1 is, and when I do this, when I run this, it's going to show me the value of A at index 1. Now you think, but there's a 0 there. No, that's index 0. Okay, and at index 1, or let's say index 3, actually index 3 is a 0. Let's go to index 4, and I can run this, and you can see, whoops, 4 is a 0. Let's see, let's do 5. Maybe that one's, but you can look at, I mean, you should be able to see these. Okay, so 5 is also 0, 1, 2, 3, 4, and 5 are both zeros. I have to pick the two that were that. 6, there we go. Let's do 6, boom, and there's the 2.7 right there, 6. Or I could just put A, run it, and it's just going to show me the A. It's going to show me the entire array. Now, but I want to fill in the blanks. Well, one thing you could do is say you could set another, you could set another array to be equal to A, so that when you're modifying it, you're modifying the copy. In this case, I really don't care because I have the array in my code right there. I don't really care about that. I don't need to make a copy before I do it. What I want to do, though, is I want to write an algorithm that will fill in one of these values. So let's do this. So I'm gonna go ahead and define a function, fill in blank. Fin in blank. Let's fill in blank. And I'd like to give it the index of the blank that I want to fill in. So now I'm going to have to go ahead and write that function. Now, if I say so, to do that, I need to find a couple of things. I need to find the lower bound. And what do we mean by the lower bound? Well, suppose I give it 0, 1, I give it 2. I give the index as 2, and that's a 0. And I want to fill in the blank. I want to fill in the 2. Well, to interpolate, I need to know the one below it, and I need to know the value above it. Okay, so I need to know the lower bound, I need to know where there's a value in the lower bound. And I need to know where there's a value in the upper bound. I also, by the way, I need to pass it the array. Oops. I can use the A if I want to because it's global right now, but let's call it, this is A1. And that will be the array. So I'm going to actually pass it the array too. What I mean by pass, this A here and the A1 in here, if I say fill in the blank and I give it the index 2 and I say A1 and I call it with A, it's going to call it with that actual array that I've defined up here. But it's going to be A1 inside of the function because we're inside of a function. I'm defining a function here. Now, what can I do here? Well, looking at this, I probably want to find the lower bound. Now, I could do this with a loop, okay? So for I in range, okay, and I'm going to go from, now, I don't know what this range is. I know that if I'm at index and I go left, then I want to stop when I get to something that's not 0. Well, maybe I don't want to go there. I don't want to use a for I in range. Maybe I want to do a while. It's another loop. So let's say I is equal to index. I'm going to set a variable I equal to index. And then I'm going to say while A of I, oops, did I get the bracket wrong? There we go. A of I is not equal to 0. Right, well, actually, I'm going to do it while it's equal to 0. Okay, now, A of I is going to be 0 in this case because the index, we know it's 0. Look at that. It is a 0. Oh, I got to put a colon here. I got to put that there. Now, what do I want to do? What I want to do is I want to make I go down until I see a value that is not 0. So, how do I do that? Well, we can say I, and I see how it just automatically puts plus equal, but I want to go down. I want to see what the left bound is. Minus equal is going to go the other direction. And then 1, whoops, we're going to go by 1, and it's going to jump out. As soon as it gets to something that's left that's not 0, it's going to jump out of that I, while. And I'm just decrementing I. And I can say L bound is equal to I. I'm going to just call it L bound. It's good enough, good thing. Okay. That's going to be, now, let's do this. Let's return L bound. And let's do this. Fill in blank. And let's call it with an index of 3, 0, 1, 2, 2, because 2 is a 0, and A. Let's run this and see what happens. It returned a 1. It returned that there. So now, and I can actually, because it returned that, I can actually say here, L is equal to fill in blank to an A. And I can actually say, what is A of L? Now, if I do that, it should return 0.5. So that's the value that's actually at the lower bound. All right, well, I don't want to return L bound. I want to fill in the blanks. That's not what the, so I got to do more. Now, let's go do this again. And notice I just copied and pasted it. Okay. This time, let's go the other direction. Plus equals 1. And let's call this U bound. Heh. Now U bound. And let's return U bound. Right? And L is going to be, now let's see what happens if I do the same thing as this A of L. Run the whole thing. Okay. Oh, hang on. We got to do something first. Now, notice it returned to 0.5. Why did it return to 0.5? Well, because I is, it's been decremented. And L bound is equal to I, but I is still what it was when we did that first loop. So I'm going to set I equal index here. So I want to go back to the index that you passed and do it again. Now notice I'm debugging as I go. Now it returns the 1.2. A of L is the 1.2. So my lower bound is 1. My upper bound is going to be 3. And the values at those are going to be A1, A of L, A of U bound, and A of L bound. Well, now we know the lower bound, and we know the upper bound, and we know the values. We can do everything that we need to do to interpolate. All right. So what is that interpolation? V. V is going to be the value. This is where you use your interpolation equation. We know the lower bound. We know the upper bound. Okay. Now, there's no checking going on here, so you can easily, like suppose I put in 1 for my index. Well, it's going to go down and you're going to go out of bounds because you're going to go less than 0. You're going to go, well, actually, if you put in a 0, so you want to check for some things here. But right now, we're just going to assume that you can put this in correctly. So the value is going to be, okay, well we've got the lower bound and we've got the upper bound. The value is going to be A of L bound, okay? This is mx plus b. This is an equation for a line. I'm not going to cover how to do this because it's not that hard. Now, it's going to be the lower one. Now you need the slope, okay? So what's the slope? It's the change in the y, delta y over delta x. So delta y. So delta y, well, that's going to be the A of U bound, the value in the array, minus A of L bound. Okay, that if I tab, okay, and actually it's wanting to do the whole thing for me. Now, what do I divide by? Its slope. It's U bound minus L bound. Okay, now I'm going to go back because but it actually did that correctly. Okay, U bound minus L bound. Okay, it's wanting to tell me. Oh, it's wanting to correct my spelling. It's just spell checking. No, don't spell check your code. Okay, so now that's the slope. And what do you multiply the slope by? Well, it should be in the same units as the U bound and the Y bound. So it's the index, the one thing that you passed. And we can return, whoops, I already returned. I can return V. All right. Now, I'm just going to take that out and that out. Now, do I know if this is going to work? Well, I hope that it's going to work, but I haven't tried it yet. Okay, it gave me 1.2. So now I'm going to look at it and go, well, why did it give me 1.2? Okay, so what do I need to do here? Well, I want to know the values that it used in this. So, and I'm going to actually put this on the other side because I like this on the other side better. And I know what it did here. And anybody who knows the interpolation equation can spot this immediately. Okay. I needed the delta between the index. So I need U bound minus index times A bound minus L bound, A of both, okay, over U bound minus L bound. Look up interpolation. You'll see that this is how you calculate the interpolation. And now it gave me 0.85. Look at that. Does that look right? Well, 1.2 plus 0.5 is 1.7. Okay, well, 1.7, there you go. It is 0.85 is right. Well, that looked okay for that specific example where the zero's there, but what about these other? So like here I got 2 zeros. So this is index 0, index 1, index 2, index 3, index 4. Let's try 4. 2.2. And now let's just throw in, for example, let's throw in 5 because this should linearly interpolate those. Okay. That one says 1.7. Let's go back to 4. 2.2. So what's going on? Let's see if we can figure this out. Well, how do you work this out? Because I mean, you're gonna make mistakes in the coding, and you're gonna want to know, well, how do I get those? How do I actually figure out what those mistakes are? And what you really want to do is know what these values are. What you could do is print, okay, to make it simple, L bound, U bound, the values. Index, let's print them all. Everything that goes in there, let's print. Index, L bound, U bound. And you know what? I don't really need to print the A and the A of those, because if I have L bound and U bound, I can just look those up. Oops. And yeah, I gotta put it's a call. Print needs parentheses. Likes those. So, and it's pretty nice about telling you. Did you mean print? So 4, 3, and 6. The index was 4. Okay, 0, 1, 2, 3, 4. And it says the lower bound was 3. Okay, and the upper bound was 5, 6. And if you really are kind of wondering, okay, what about the values? Pretty straightforward to throw those suckers in there. See what I'm doing? So the index is 4, but the values are 1.2 and 2.7. So, okay, so what we've seen here is that the numbers that are coming back from that print statement, the index is 4, this is the 1.2, which is the 3, this is the 2.7, which is the 6. Those are what we expect them to be. So A of U bound minus A of L bound, those actually make sense. So that looks okay. U bound minus L bound, well, that we know, we saw what those were. That was the 6 and the 3. So this is 6 minus 3. This is going to be, now you see where my error is? I'm hoping you see this. I went U bound minus index, but I was going the opposite direction. What do I need to do here? It actually should be index minus L bound. Okay, so you saw, I wanted you to know how to fix that. Now, I spotted it when I looked at that. Okay, well now it gives me 1.7, which actually makes sense that it'd be 1.7. And if I call it with a 5, it should return the 2.2. And now the numbers actually make sense. I don't need this print anymore. Okay. Now, how can I actually set the array to fill in the blank? Well, if I want to say A of 4 is equal to fill in blank, passing it the array. Now watch what happens. And then let's print out A afterwards. Okay, now that 1.7 has been inserted into the array, into the missing spot, because the fill in the blank returned that. Nope. I threw in an error, figured out the error by adding in a print, looking at it, doing some reasoning, and figuring it out. You will be doing this. And this is a relatively simplistic algorithm to fill in the blanks of this array. Now, if I was going to do this all by hand, I could go ahead and do all that. I mean, if I was going to do it by hand, I could check all this. So I'm going to leave it here and let you guys work from here. And if there's questions, I'll help you out. Okay?